what I've learned in the last 30 years is that the evolution paradigm is kept going not by scientific evidence, but by religious devotion to naturalism, that prior commitment to a naturalistic worldview. And I think it's very sad because science should be open.
ID the Future, a podcast about evolution and intelligent design.
Evolutionary theory predicts a living world crowded with substandard designs. But as today's guest will reveal, the latest science has discovered just the opposite, designs so advanced they're at the limit of the possible, precisely as proponents of the theory of intelligent design have anticipated. Welcome to ID the Future. I'm your host, Andrew McDiarmid, and it's my pleasure today to welcome to the show award-winning British engineer and designer Stuart Burgess to begin a two-part conversation with me about the extraordinary systems and devices that demonstrate what Burgess calls ultimate engineering. Now, if you don't know Dr. Burgess yet, let me just fill you in on some of the details. He is Professor of Engineering Design at the University of Bristol. He has published over 200 scientific publications on the science of design in engineering and biology. In the last 3 Olympics, he was the lead transmission designer for the British Olympic cycling team, helping them on each occasion to be ranked in first place for track cycling. For the last 2 decades, his gearboxes have been used successfully on all the large Earth observation satellites of the European Space Agency. He has received many national and international awards for design, including from the Minister of State for Trade and Industry in the UK. In 2019, he was given the Top Mechanical Engineer Award in the UK out of 120,000 professional mechanical engineers. And he has been an invited speaker in over 30 countries. Stuart, welcome to ID the Future.
It's good to be with you, Andrew.
Yeah, thanks for joining me today. Well, it's a delight to talk to a fellow Brit, and I was born and raised in Edinburgh before my family immigrated to the United States when I was 11. Tell us where you were born and raised and what got you into science and engineering.
Well, I was born and raised in Bristol in the south of England. I think one of the things that drew me to engineering, when I was a very small child, I really loved playing with Technic Lego. And I was really fascinated how you could create so many different designs just from one set of components. So I loved that creativity, and I think that stayed with me my whole career. But then as a teenager, I was very keen to get involved in high-tech technology like spacecraft engineering and robotics. So I studied mechanical engineering at university, also did a PhD in mechanisms design and research. And then I was very blessed and fortunate to actually get a job with the European Space Agency. So that's really my background.
Wow. Must have been rewarding to be able to work on actual spacecraft and rockets and satellites after thinking about that for so long growing up. I mentioned this when I introduced you at the beginning of the show, but I'd like to bring it up here as we begin. In 2019, you received the annual James Clayton Prize, the most prestigious prize for mechanical engineering in the UK. So what did you do to get that prize?
I think this was really for 3 particular contributions to mechanical engineering science. Firstly, my design of robotic arms for the European Space Agency. I think you were just mentioning my robotic arms, my gearboxes are used on ESA's 4 largest Earth observation satellites. So that was really extending the boundaries of what was possible for large satellite sizes. Secondly, as you mentioned in the introduction, my work for the British Olympic cycling team, that before I joined the design team, we were not really winning that many medals. And for my first project with the Rio Olympics, we were particularly hoping to beat the American team. So having achieved that, that was definitely one of the reasons for getting that award. But then thirdly, for my biomechanics research on animals and humans, I've written a number of review papers on things like linkage mechanisms in animal joints, and they've been quite highly cited. So it was really a combination of those 3 things. But one common factor would be precision mechanical engineering.
Yeah. That's great. Well, what motivated you to write the book Ultimate Engineering, which is the subject of our conversation today, describes the amazing biomechanics, not in rockets or satellites or even Olympic bicycles, but in the human body. What brought you there?
Yeah, so I suppose my main motivation was to show that scientific evidence supports intelligent design. I've been in a fairly unique position in working both in engineering technology, but also working biologists, working in areas like biomechanics and bio-inspired design. So I have this unique position of being able to compare those two different fields. And what's very clear to me is that the standard of design in biology is superior to that we see in engineering. And
Mm.
uh, because the process of evolution is so restricted to incremental change, that shouldn't be the case if we were just here by chance. So that superiority of design in biology, I see as an important evidence for intelligent design.
And at what point did you say, well, I just have to get this into a book? I've got to consolidate it into a unit that I can then share with people more easily.
I think this was about 5 years ago. I managed to get a research fellowship at Cambridge University at Clare Hall College, and I was doing some of the latest research on animal joints, how they're multifunctioning, how they have linkage mechanisms. And when I saw some of the latest research, how superior the human body is compared to humanoid robots, for example, I thought this needs to be put into a book, because what I was noticing was that design in biology is not just very good. I was noticing that it was at the limit of what is physically possible. And so I then had this concept of, yeah, this is ultimate engineering. And that's really when I was motivated to produce the book.
That's fantastic. Well, first, your book presents the evidence for optimal engineering and answers the claims of bad design, which of course are motivating you and you've done a great job of responding to. The second section of your book reviews the explanations for optimal engineering and reviews which theory best explains the evidence. So I like that two-part idea behind the book. What are the aims of your book as you've set them out? What do you hope it will accomplish?
Yeah, I think the main aim is to show that the human body has ultimate levels of engineering right from head to toe, and putting forward the latest, really the latest research, literally from the last few years. I hope that people enjoy the chapters, but also that they see there's this, what I would say is overwhelming in evidence for intelligent design. And then, as you were mentioning, a second aim is to show there are these claims of bad design, which are really just false and go against scientific evidence. I think the reason there are these claims coming out is that evolution predicts bad design. The reason evolution predicts bad design is that it's so constrained by good enough design, by step change. And so people like Nathan Lentz, Richard Dawkins, Abby Hafer, their thinking is based on what evolution predicts, not on the actual scientific evidence. And I want to show that in my book.
Yeah, and that's absolutely key here. And what is wholly original and provocative about your book, I would say, because not only are you taking on Charles Darwin's view, you're also taking on Darwin's Latter-day Saints, as it were, who are then picking up the mantle and saying, look, this is what we should expect given a bottom up. And so I'd argue that this is what we see. But I don't know how they have a leg to stand on, especially after you're pointing out the optimal engineering. Um, Now, some people will object that disease and genetic disorders are signs of bad design. You address that in the book. How do you answer those objections?
Yeah, I think it's very important to answer these objections. I noticed in Nathan Lent's book, he also mentions, well, disease is a sign of bad design, but he's really incorrect, because anyone who understands design knows that there's a difference between disease and design. And it's possible to give an illustration. If we see a quality motor car getting rusty, that's not a design fault. It's something that happens naturally to cars. In the same way, if someone is unfortunate, they get arthritis in their joints, that's not due to bad design. That's a factor of being in a decaying world. And the same is true of genetic disorders. Obviously, it's not very nice if you're born with a genetic disorder that makes you blind, but that's not design. That's another sign of decay. If you buy a brand new motor car and it has a fault because there was an error in the drawing that made the car, that's not a fault in the original design. It's a fault in the decay of information. And so in my book, I explain that living organisms would have been originally created, designed with this ultimate engineering, but now we obviously live in a world which is in a state of decay. So when I talk about ultimate engineering, I'm saying you have to put to one side diseases, genetic decay, and if you can do that, then you are observing ultimate engineering.
Yeah, yeah. Separating the effects that can come after something that's designed from the design itself. I'm not sure if it was Stephen Meyer, but I read a lot of material interviewing ID scholars and scientists, and somewhere I came across the term aboriginal design, and I latched onto that because I like that because it's a way of describing the original design and intent and function as opposed to what might be evident today or under some sort of duress or disease. So similar to what you're talking about. Now, several chapters of your book deal with human joints, like the ankle joint, knee joint, and wrist joint. The author, Nathan Lance, claims that these joints are badly designed, as you've mentioned. Why does Lance make these claims, and how do you answer him?
Yeah, so Lentz makes these claims based on what evolution predicts, as I was saying, but I can give a specific example of this. Nathan Lentz says there was not enough time for a quadruped ape-like creature to evolve into a biped human. And I agree with him that there's just not enough time for so many design changes to take place for a quadruped ape to evolve into a human. So he's correct. With that, there's not enough time. But where he's wrong is that humans are not a badly designed biped. The fact that we are so wonderfully well designed in our feet and our legs goes against the theory of evolution, because according to evolution, it should be impossible to do this. So Lentz is looking at theories of human evolution and then saying, if humans evolved, we must be full of bad design. But in fact, I agree with him on that point. But the evidence absolutely point to the fact that we are very well designed. Just to give one specific example, Nathan Lentz claims that we would be better without a fibula in our lower leg. He says it's pointless to have two bones in our lower leg. But Lentz is unaware of scientific research, which shows that our fibula is essential for the stability of our ankle. And Lentz claims that we would be better with ankle joints that were fused together. And again, he's unaware of the scientific research showing that the ankle joint is brilliantly designed and all of the subjoints within the ankle joint are really essential. And really, Lentz in his book is a classic example of what happens when you don't follow the scientific evidence and instead you follow an evolutionary ideology due to a prior commitment to that materialistic worldview.
And with all due respect to Mr. Lentz, I think he needs to attend engineering school, and this will be a theme as we're discussing these things, but having that understanding, that deep appreciation, understanding, and intimacy with engineering principles is really a prerequisite of studying living forms, I would say. We're getting to the point where that is becoming quite obvious. But how do you train all these biologists in that? That's a separate problem. Now, you have a chapter on the mouth and the throat. The author Abby Hafer claims that the throat is bad design due to the possibility of choking. How do you respond to that?
Yeah, once again, Hafer is running away with the evolution ideology. The human body must be full of bad design. The throat is a multifunctioning structure in three main ways. We can eat with our mouth and throat. We can speak. We can sing. We can also breathe as well. And every engineer I know who's studied the mouth and throat, and also every biologist, is amazed at the incredible design of the throat and mouth. In particular, there is a very precise coordination of muscles. When you swallow, you have something like 20 muscles working in split-second coordination to make the swallowing process happen. I can say the same about speaking and singing. The throat is an amazing design. And if you actually look at the scientific research, the researchers are full of praise for the throat. Abi Hafer's only criticism of the throat is that if you're not careful, that there's the problem of choking. Now, the answer to that is that there are many things in life where you have to be careful. Our eyes and ears are quite delicate. So if you're in a sandy environment, then you have to be careful with your eyes. If you're in a loud environment, you have to be careful with your ears. So yes, you need some care and attention not to speak and eat, exactly at the right time. But the fact is, choking is actually very rare unless you have some degeneration. Some elderly people have problems with swallowing. But if you're a fit and healthy person, choking is not a problem. Engineers would love to be able to design something as well as the mouth and throat. And in fact, in recent times, robotics engineers are realizing that they need to pursue multifunctioning design much more in order to improve the performance of robots. But Avi Hafer is just unaware of this research.
Yeah. Well, let's talk about another amazing component of the human body, the human eye. Now, even Charles Darwin admitted his theory would struggle to explain the eye, yet we've seen evolutionists make the claim that the eye is wired backwards because light has to pass through the retina to get to light-sensitive cells at the back of the eye. How do you deal with that claim in the book and in your work?
Yeah, this is something I go into some detail because it's an interesting historical kind of story. This is a classic example of someone or an evolutionist looking at something they don't fully understand and making a knee-jerk reaction. Well, this must be badly designed. But over the last 15 years, the clear scientific research is that the eye is most certainly not wired backwards and not a bad design. Right back in 2010, some researchers discovered what are called Muller cells, which are like fiber optic cables that guide light through the retina. So that light is not decayed. In fact, it's quite the opposite. It actually does signal conditioning. What was previously thought to be a design weakness turns out to be a great design strength. And in 2015, Scientific American came out with an article highlighting this research, that the eye is not wired backwards. In the last few years, there have been more papers. One paper, I think in the title, says the eye is near perfect. And yet, authors like Richard Dawkins, Abi Hafer, and Nathan Lentz, even after these scientific discoveries, are repeating the false claim that the eye is wired backwards. Again, it shows you, I think, two things. Firstly, the danger of having this prior commitment to a materialistic worldview and ignoring the evidence. But it also shows it takes a long time to clear up the false signs. It can take a decade to get people to change their books, change their websites, to correct these false statements.
And, we recall that materialism is such a stubborn view when you're holding tight to it that no matter what evidence comes along, you're going to be unwilling to let that go often, barring a complete 180.
Yeah.
So that can get in the way too. And can I just, I want to toss in this extra question here. I know it wasn't in our notes, but I do feel it's so important to note the importance of trade-offs, in engineering. And I know you can speak to this, and we don't have to belabor the point, but I just want to make it abundantly clear that trade-offs are a reality for engineers. All of the questions that go into dimension and size and function and even the looks, the aesthetics of something. There are so many questions. I'm sure you can point to just flowcharts of dozens, if not hundreds, of questions that get explored in a project. What would you say about the importance of trade-offs when considering engineered systems in life?
Yeah, this is a really key point. Engineers spend a long time learning how best to do trade offs. If you're designing a car, you cannot design a car that is really high performance at the same time as very high environmental performance, at the same time as high ergonomics and high aesthetics. Every car is a compromise and a trade off. For example, this is something that Abby Hafer clearly didn't understand with the human throat. You can't be good at absolutely everything. There's got to be some trade off. In fact, in her book, Abby Hafer says the creator should have made humans like a whale with a blowhole in the back of our neck. Now, if we had a blowhole in the back of our neck, we would need two mouths, two sets of lips, two tongues. It would be just a ridiculous design. Our design, which is multifunctioning, is clearly the best design. You can't just separate out all of the functions. And so that was a key error that Abby Hafer made. She did not understand the necessity and importance of trade-offs.
Yeah. And I want to make the twin point that if you don't have a brain and you can't see, you can't make trade-offs. You can't be an engineer. And I'm talking obviously of the blind, undirected process where natural selection is the mechanism to drive evolution. But if you cannot see and you don't have a brain to think through the questions and possibilities, you can't do trade-offs. You can't be an engineer.
Yeah, that's such an important point you've just made, because last year I published a paper on multifunctioning in animal joints, published in the Journal of Biomimetics. And I had a paragraph saying, when you have multifunctioning, it has to be planned ahead. And the reviewers allowed me to make the statements, this therefore is a major challenge to evolutionary biology. And they allowed me to put that comment in the paper.
That's great. Yeah. Because it's, you're just telling the truth at that point. And I know it can be hard to swallow from a reductionist, bottom up view, but it's the reality you've got to face eventually. And Stuart, I don't know how much you've read of Bill Dembski's work. I'm sure you've read quite a bit, but I just interviewed him on his law of conservation of information. And, he talks about information as the narrowing of possibilities. And the only beings in the universe that can actually perform that act is intelligent beings, AKA human beings. And and other forms of intelligence in the universe. And so that's key too, only intelligent beings can manipulate information and function as engineers, as we're talking about here. Anyway, I just thought that was definitely worth mentioning in the context of all of this. Now, in another chapter of Ultimate Engineering, you explore the biomechanics of the inner ear. And there's three tiny bones there. Evolutionists claim that some of the tiny inner ear bones evolved from reptile jaw bones. What do you show in your book?
Yeah, I think this is an important point, because many children in high school and colleges are told this story about how two bones in a reptile jaw, one from the upper jaw, one from lower jaw, supposedly migrated into an ear, so that eventually from reptiles to mammals, mammals ended up with three bones in their ear, whereas reptiles just have one bone in their ear. But in my book, I show that the inner ear is a very complicated design. It's not just three bones. There are also two muscles and lots of ligaments that suspend the bones in space. It's a very special kind of joint. Instead of having joints between the bones and the rest of the ear structure. They're suspended by these ligaments. And so there are many components in the inner ear. It's not just three bones. And there's incredible engineering in the ear such that we have this acoustic reflex. If there's a very loud noise, the muscles can tension and pull the bones in different directions, which protects our ears. It can also adjust the stiffness of the system if we're trying to hear very soft sounds. So the reptile to mammal evolutionary story doesn't begin to explain the actual complexity of the inner ear. It's a real challenge to evolutionary theory.
And it sounds cliche at this point to say, oh, well, animals are just, or animals and humans are just too complex to be explained through evolution. That's sometimes how you see our view, the intelligent design view, characterized. But at the end of the day, that complexity demands an answer. And, we haven't seen any satisfactory answers coming from a Darwinian evolutionary view. And that's why we keep pressing, which view is most adequate to explain that complexity in design. Now, here's another question for you. In the media, at least in the last few decades, media outlets tend to give the impression that no serious biologists believe in intelligent design. But that doesn't quite match your experience, I don't think. What have you sensed, and do your academic colleagues think of intelligent design in a good light or a bad light?
Yeah, I've got a couple of chapters in my book dedicated to this because I think people will be fascinated to know what people actually think in academia. I've been in academia more than 30 years, and I think my biggest surprise is how many academics are at least sympathetic to the whole concept of intelligent design, even if they don't want to admit that in public. This idea that biologists reject intelligent design, it's a really big myth. Just to give an example, in my book, there are 10 people who write commendations at the beginning. There are 10 who are academics or medics, very, very high qualified people. One of those, for example, is Professor Alan Linton. He was chair of the Department of Microbiology at Bristol University. He was a very, very senior biologist, right at the top of that field. And yet he wrote the foreword to my book saying he totally agrees with the whole concept of intelligent design. But I've also met with many biologists at my university and other universities, and they say that they can see that there's virtually no evidence for abiogenesis, very little evidence for macro design, but they don't want to say that in public because they know it could affect their career, they could be criticized. What I've learned in the last 30 years is that the evolution paradigm is kept going not by scientific evidence, but by religious devotion to naturalism, that prior commitment to a naturalistic worldview. And I think it's very sad because science should be open.
Sobering indeed. Well, final question for you in this segment. You've published 200 scientific papers on design and engineering and biology. In your book, you mentioned not only being awestruck by the engineering marvels of the biological realm, but inspired by them to make significant breakthroughs outside of biology. So it's not just something like, wow, this is great, and then you're moving on with your day job. You're actually inspired to do things in your day job based on what you're seeing in biology. So how has this belief in intelligent design helped you be so productive in your research?
Yeah, there's no doubt whatsoever. My belief in intelligent design has been an enormous help to my work, inspiring me not just in an emotional way, but really in a scientific way as well. When I study biology, when I see complexity, I don't think, well, that could just be a chaotic origin. I think that complexity probably has a sophisticated reason. I need to investigate it. For example, when I first looked at the human foot, it's an incredibly complex design. But I made the assumption there must be design intent there. There must be some top-down architecture. There must be a reason. And I did find reasons for the design of the foot, and it enabled me to write several papers on the foot. One of them a prize-winning paper. If I'd had an evolutionary worldview, I would have thought, well, the foot must be a bad design because evolutionists like Nathan Lentz are telling me that there wasn't enough time for the foot to be evolved, but I didn't listen to them. I had an intelligent design worldview, and I know other researchers, Andy McIntosh in the UK, other researchers who've had the same worldview, and that has inspired them to do better work and more successful work in biomimetics and biomechanics. And I would say those who believe in a creator stand shoulder to shoulder with the greatest scientists who ever lived. Isaac Newton, James Clerk Maxwell, Lord Kelvin. They would also say that their belief in a creator God, their belief in an ordered world inspired them to pioneer science. So I think this is the same lesson throughout history, that intelligent design is the best worldview.
Yeah, I was going to add that you are in very good company. Those who see the design and are able to study it because of the belief in a top-down, meaningful, purposeful design and complexity. Well, Stuart, we're just warming up here. I'd like to come back in a separate episode to continue exploring the evidence you present in your new book. There's tons more here. We're just scratching the surface. Thanks for your time in this episode, though.
Yeah, thank you. Good to be with you.
Well, audience, if this is piquing your interest and you'd like more detail on the stunning engineering prowess on display in the human body, you can get a copy of Dr. Burgess's book and read it for yourself. You can learn more and order a copy at the website of Discovery Institute Press. That's discovery.press. Discovery.press. And join us in part 2 for more of Ultimate Engineering with Dr. Stuart Burgess. For ID the Future, I'm Andrew McDiarmid. Thanks for joining us.
Visit us at idthefuture.com and intelligentdesign.org. This program is copyright Discovery Institute and recorded by its Center for Science and Culture.